Hello friends, welcome to session 2 of projection of solids. That means in this section we're continuing with the projection of prisms. This problem says, that is problem 3, a square prism of base size 35 and axis 60 has one of its base edges on HP with its axis inclined at 45 degrees to HP. Draw projections of this prism and axis is inclined at 30 degrees to VP. Assume bottom surface of the square prism is nearer to the observer. It clearly says draw projections of the prism and axis is inclined at 30 degrees to VP means you know very well under such circumstances you have to undergo beta constriction, which will be explained later in this session. Now you see here, this problem is similar to the last problem. That is, a square prism of size 35 and height 60 has one of its base edges on HP with axis inclined at 45 degrees to HP. Up till here it is same. But the third condition says, keeping inclination 45 degrees to HP constant, this prism has to be rotated such that the axis should be inclined at 30 degrees to VP. But axis should be inclined at 30 degrees to VP means it is clear that true length of the axis should be inclined at 30 degrees to VP. But here we don't have the true length. Under such circumstances, we had to undergo this beta construction. Okay, what you do now is, after this, draw a line at 30 degree, cut O1 OX equal to the true length, which is 60. O1 OX equal to 60 and draw the locus line here. Then take the second stage top view length, that is O1 O. This length you take, from O1 you cut it here. Once you cut it here, you get beta. This is important to us. Now this top view, that is the second stage top view, should be tilted in such a way that O1 O should be inclined at beta to XY line or VP, so that the true length of the axis is inclined at 30 degrees to VP. Is it okay? Now what you do is, you move and copy and paste it here and rotate in such a way that O1 O is inclined to beta to XY line or VP. See here, I have brought it, I have copied it to this, moved and copy, then I'll rotate it such that O1 O is inclined at beta to XY line or VP. Okay, in this position you are supposed to write the front view. The procedure remains same as I've said. Okay, on this you should get A and B, on this you should get C and D, on this you should get A1 dash, B1 dash, and this you should get C1 dash, D1 dash. Okay, that means all 8 points you locate here first. Okay, next step, the first step is obtain all the points and join the outer boundary of these points by dark lines. If you do this, more or less it is over. Only now the second step says, when you compare bottom surface with top surface, when you are looking from here, bottom surface is nearer to the observer than the top surface. When bottom surface is nearer, darken the bottom surface and immediately remaining edge of the other surface, make it dark dotted. You see here, I have darkened the bottom surface, which is nearer, and immediately remaining edge of the other surface, make it dark dotted. In that way, 4 plus 4 plus 2, 10 edges over. Then you are left with only B dash, B1 dash and D dash, D1 dash. Okay, as a third step, you just see all nearer edges are darkened, all far away edges are made invisible or dark dotted. Now B dash, B1 dash, if you see BB1 is nearer, hence you darken it. And since D dash, D1 dash is back edge, DD1, if you see here, when an observer is looking from here, DD1 is back edge, hence D dash, D1 dash is made invisible, dark dotted, and show the axis finally. This completes the problem. The problem is a square prism of size 35 and height 60 has one of its base edges on HP with axis inclined at 45 degrees to HP and 30 degrees to VP. and you have done beta construction, which has to be shown clearly even in the exam, because for this construction itself you have the maximum mass allotted. Okay, now we'll go for projection of pentagonal prisms. The pentagonal prism looks this way. You see here, this is the pentagonal base, 5 edges. This is the pentagonal top surface, 5 edges. 5 vertical edges, 1, 2, 3, 4, 5. That means in these problems, you should know that you have to manage 15 edges, and in the front view and top view, you have to take care of the edges because some of the edges will be visible, some of the edges will be invisible. You have to take care of all those important crucial points. Okay, now problem 4, it says a pentagonal prism of base side 60 and height 125 has one of its base corners on HP. That means corner is on HP with base inclined at 50 degrees to HP. Draw projections of this prism when top view of the axis is inclined at 50 degrees to VP. Assume bottom surface of the prism to be nearer to the observer. But whatever it is, you see here. Now you write the prism in this way. Hope you know you should manage 15 edges here. Draw 60 mm pentagon. Since the dimensions are big, you take a scale of 1:2 so that this will be 30, 30, 30, 30 and 30. In that way, 30 mm pentagon you draw and name it as AA1, BB1, CC1, DD1 and EE1. Okay. Now as you see, A, B, C, D, E will represent top surface. At the bottom, A1, B1, C1, D1, E1 will represent bottom surface. A1, BB1, CC1, DD1, E1 will represent 5 vertical edges, totally amounting to 15 edges. Then you take the front view. When you take it to the front view, you can see 5 edges here, 5 edges here, BB1 merging with A1 vertical edge, CC1 merging with E1 vertical edge, and DD1 is another vertical edge. 5 here, 2, 2 and 1. Totally 15 edges are there, and draw perpendicular bisector from any two sides. Then you get O1, which is axis point. O dash and O1 dash will be the axis here, axis symmetry. Okay, now you see here in this problem he says clearly it is a corner on HP. You see here this prism, if I turned left, it would have rested on B1A1, that is edge on HP. But what I want is corner on HP. That is why tilt right. That is this position. If you take this position for pentagonal prism, you can either make corner on HP or edge on HP depending on how you rotate. Now I have rotated right such that D1 dash bottom corner is on HP such that the base is inclined at 50 degrees to HP. Okay. Now if you see, you take all the points to the other view. And as I said, first step, see here, D here, C and D here, AB here, D1 here, C1, E1 here, A1, B1 here. This is the top surface, this is the bottom surface. Okay. Once you get all the points, as a first step, join the outer boundary of these points. Okay. First step is over. Next, compare top surface with bottom surface. Since top surface is nearer, darken the top surface and immediately remaining edges of the other surface make it dotted. Now, if you see here, I have darkened the top surface, immediately remaining edges of the other surface make it dotted. In that way, 5 plus 5 plus 2, 12 edges are over. You have to complete another 3 edges, totally 15 edges. Now, when you are looking from here, AA1, BB1 are nearer edges. As a result, both can be seen. DD1 is the back edge. When you are looking from here, you can't see it. As a result, you make it dotted. Now, you see here, AA1, BB1 I have darkened it, and DD1 I have made it dotted. And show the axis finally. Bring O here, bring O1 here. Axis is this. Axis, one big, one small dot, 0.13 mm thickness. That axis representation can be made only between D1 and O1, though axis exists between O and O1. Because in this, up till here, DD1 invisible edge is existing. As a result, you give preference to that and give prefer access only between D1 and O1. But actually access is O to O1. Now you see that what exactly he says is top of the axis is inclined at 50 degrees to VP. Then move, copy, paste and rotate with respect to O1 so that the top of the axis is inclined at 50 degrees to VP. In this position, you have to write the corresponding front view. You see here, since the inclination is kept constant and rotated with respect to VP, this top view will not change. That is why the second stage top view and the third stage top view will remain same. Now what you do is, as usual, you get all the points in the other view. You see here, on this AB, on this C and D, on this carefully you see D, okay, D, on this A1, B1, okay, B1, A1, on this C1, E1, E1, C1, on this T1. That means all these points clearly using point command make clear dots of 2 mm thickness. Otherwise, you will get confused. Okay, make 2 mm thickness point and here you make a dot A1, A1 dash, A dash, B dash, make a dot here C dash, C dash, make a dot here D dash, make a dot here A1 dash, make a dot here B1 dash, E1 dash, C1 dash, D1 dash, all dots you do so that even these complex problems would look very easy to you. Now, once you have all the points here, as I told you, the first step, darken the outer boundary of the points. You darken the outer boundary of these points. First step is over. Next step, second step, compare top surface with bottom surface. In this case, when you're looking from here, bottom surface is nearer to the observer. Hence, bottom surface is darkened and immediately remaining edges of the top surface make it dotted. Okay, in that way you see here, bottom surface are darkened red, immediately remaining edges of the other surface make it dotted. Okay, then you see here, then once you do this, the remaining edges BB1 is the nearer edge, you immediately darken it, and actually DD1 actually it is going little away. You may, if you expose it, if you enlarge it, you can see D dash to D1 dash is actually dotted. If you otherwise, it looks as if it is merged with this. In that way, you are able to complete the projection of prism in this position. See here, the procedure I'll repeat. Take all the points to the other view, join the outer boundary of these points. Since bottom surface is nearer, darken the bottom surface. Remaining edges of the other surface make it dotted. In that way, 5 plus 5 plus 2, 12 edges will be over. Okay. Then CC1 can be darkened and BB1 can be darkened because they are comparatively nearer. CC1 and BB1 comparatively nearer, and E1, that is the 15th edge, is far away, make it dotted. If you enlarge this area, you will know correctly what exactly is happening here. That is why I'll repeat. After the outer boundary, darken the bottom surface, remaining edge the other surface, make it dotted. In that way, 5 plus 5 plus 2, 12 edges you would have already got. Okay. In that way, you finally you do this CC1, BB1 and E1 and take care. E1 being the faraway edge, make it dotted. Okay, and finally show the axis. Okay, in this way we have completed the session 2 on projection of prisms. Thanks for watching. Thank you.